Formulation of decision-making problems. Real-life situations demand for decisions, and there is ever-growing quest for the best decision. That is what we call as the optimal solution. There is a need of scientific approach so that we can justify the optimal solution that we have. The search for the optimal solution begins with the problem formulation. What is problem formulation? Problem formulation is understanding the situation carefully and representing the situation with the help of mathematical model. So the learning objectives of the present video are: identify decision variables, determine objective function, construct algebraic expressions for constraints. Now let us see a problem. Say here we have a problem which is called as a product mix type of a problem. There are two products. Say let us say two models A and B which are produced in one particular say industry. Then these products A and B are having unit profits as given in the table. The processing time required for each product for two different machines P and Q also varies, and the data is given in this particular table. The processing time by machine P required for product A is 5. Like that, say all data is given in this particular table. Now we want to formulate this as a decision-making problem. Now the step 1 is to identify decision variables. That means, first of all, we have to decide what is to be decided. And once we decide the decision variables, we can assign the variables such as x, y, etc. to the entities to be decided. In real life, there can be any number of variables. However, say in the present problem, there are only two variables to be decided, and let x be the number of A-type models to be produced, and let y be the number of B-type models to be produced. So x and y will be the decision variables in the present problem. Now the next step is to identify objective function. Obviously, the aim will be to maximize the profit, let us say Z. Z will be the total profit, which will be equal to 3 into x plus 4 into y, because 3 and 4 are the profit, say, coefficients for the particular model. So the objective function will be maximize Z equal to 3x plus 4y. Because the resources are limited, there are constraints, and we have to identify the constraints. As machine hours are limited, values of x and y also will be limited. So the constraint due to machine P will be 5x plus 6y, that is the total time required for machine P for producing both the models. So that must be less than or equal to total available, that is 240. Similarly, for machine Q, we may write 4x plus 3y must be less than or equal to 150. Further, x and y say cannot become anytime say negative. So x and y has to be greater than or equal to 0. Finally, say the mathematical model for the problem can be written as maximize Z equal to 3x plus 4y subjected to 5x plus 6y less than or equal to 240, 4x plus 3y less than or equal to 150, and x and y must be greater than or equal to 0. So far we have not seen how to maximize or how to obtain the optimal solution for this particular mathematical model. But the most important step is to formulate the problem. Then we can adopt various methods for obtaining the optimal solution. Thank you.